So good morning girls. Today we are going to talk about what are the different data transfer schemes. What are the three different data transfer schemes? So today we will be covering only one scheme, which will be the programmed input output, and probably if time permits we will also discuss interrupt initiated input output. So yesterday during the discussion I told you the CPU has to be connected to the different peripheral devices and the memory. When the CPU is transferring the data between these components, there is going to be a speed mismatch between the data transfer rate of CPU and the memory input output devices. To solve this particular problem, we have three different data transfer schemes: programmed input output, interrupt initiated input output, and direct memory access. Let us see what is programmed input output. The programmed input output is used when you have input output instructions inside a computer program. So this mode of transfer will be initiated. This mode of transfer will be initiated when the input or output instruction in a program is executed. So you might have written some of the assembly programs for 8085 or 8086. So in your assembly program, if you have an input instruction or an output instruction, during the execution of this instruction, the mode of programmed input output data transfer will be initiated. So when this data transfer is initiated, the data will be transferred from the CPU to the peripheral devices. So in the CPU also you will have registers like A register, B register, or you have registers like AX, BX. So in those registers you will be having the data, and these data can be moved to the peripheral devices. Now when you want to transfer the data, you need some kind of instructions to transfer the data from the CPU and the memory also. Sometimes the data may not be available in the CPU register. The data may be available in the memory. You want to transfer the data which is available in the memory to the input output device, which cannot be done in the direct data transfer. So what you will be doing? The data will be transferred from the memory to the CPU, then from the CPU to the input output device. So this is how the data will be transferred in the programmed input output. I repeat, the data cannot be directly transferred from the memory to the IO device. So what you need? You need other instructions to transfer the data to and from the CPU and the memory. Now whenever we are doing this data transfer, the important requirement in this mode of data transfer is the CPU has to constantly monitor the peripheral devices. The CPU has to constantly monitor the status of the peripheral devices. This is one of the requirements of this particular mode of data transfer. So once the data transfer is initiated, the CPU is required to monitor the interface to see whether the transfer can be done again, or whether the transfer can be done from the CPU to the output device, or from the input device to the CPU. So to do this continuous monitoring, so when I say the CPU has to monitor the peripheral devices, obviously CPU is a processing unit. How the task will be done by the processing unit? There will be a program in the processing unit which will be executed. So for any task to be done by the CPU, you need a program. The same way, for doing this status checking also, the CPU will be staying in a program loop, because it has to continuously monitor. So it is going to be in a program loop. until the input output device indicates that it is ready for the data transfer. And not only that, this is going to be a time consuming process. Why? Because the imagine, okay, why it is going to be time consuming process. Let me explain this way. You have an in instruction, that means you want to read a data from the keyboard. So what you will do in your 8085 program, you will have an in instruction. So the in instruction says that you need to get the data from the keyboard, because keyboard is the input device. Fine. Now, until the user presses the key, the CPU has to wait, because the data is not yet transferred from the input device to the CPU. Only when the user presses the key, the data will be transferred from the keyboard to the CPU. Correct? So if this is the case, until the user press the key, the CPU will enter into a program loop. Why? Because it has to check whether the data is transferred from the input device to the CPU. So for which it will be entering into a program, and the program will continuously check whether the data is transferred from the input device to the buffer. അങ്ങനെ ബഫറിലേക്ക് ഡേറ്റ വന്നു നോക്കാൻ വേണ്ടിയിട്ട് എന്താ ചെയ്യാത്? ഇറ്റ് വിൽ ബി കണ്ടിന്യൂസ്ലി ചെക്കിംഗ് ദ status of the input device. So input device in the status ready എന്ന് പറഞ്ഞിട്ടുള്ള status വന്നിട്ടുണ്ടെങ്കിൽ what the CPU will do? It will be reading the data from the buffer. So that is why we say it is a time consuming process. Suppose for 3 seconds you did not press the key. So what happens? For all these 3 seconds, the CPU will be continuously checking the status, because it can process only after receiving the data. It has not yet received the data from the keyboard, so it can go for processing, any other processing, only after receiving the data. That is why we say it is going to be a time consuming process, because it keeps the processor busy. How? The processor will be continuously checking the status of the input device or the output device. So in the programmed input output, data will be exchanged between the processor and the input output module. Input output module is nothing but the interface unit, and for which what the processor will do? The processor will execute a program that gives the direct control of the input output operation. What do you mean by control of the input output operation? It is going to sense the status of the device, and it will be sending a read command or a write command, or it is going to transfer the data. So all these control will be done by the CPU itself. So whenever the processor is issuing a command to the input output module, it will be waiting until the input output operation is complete. So what do you mean by input output operation is complete? You give in instruction, the processor will wait until the key is pressed by the user. Or suppose if a character is to be printed on the monitor, the CPU will give this character to the interface, and it will wait until the interface displays the character on the monitor. That is what you mean by it must wait until the input output operation is complete. So if the processor is faster than the input output module, then obviously you are going to waste lots of time. Lots of processor CPU cycle will be wasted, because comparing to the speed of the input output or peripheral devices, the CPU is much faster. So നിങ്ങൾ ഒരു കീ പ്രസ് ചെയ്യുന്ന ടൈമിൻ്റെ ഉള്ളിൽ the processor can execute lots of instructions അല്ലേ? So what happens now? Until the user presses the key, lots of CPU cycles will be wasted, because it is going to keep on checking the status of the input device to understand whether it is ready for data transfer. So that is why we say the processor time will be wasted. So this is the program which will be executed by the CPU when it is entering into the programmed input output data transfer scheme. So what it is going to do, the CPU is issuing a read command. ഒരു കീബോർഡിന് നിങ്ങൾക്ക് ഒരു ക്യാരക്ടർ റീഡ് ചെയ്യണം. അപ്പോൾ വാട്ട് യു വിൽ ബി ഡൂയിങ് ഇൻ യുവർ പ്രോഗ്രാം 8085 അല്ലെങ്കിൽ 8086 എന്ന് പറഞ്ഞിട്ടുള്ള പ്രോഗ്രാമിൽ യു വിൽ ബി റൈറ്റിംഗ് ആൻ ഇൻ ഇൻസ്ട്രക്ഷൻ. So when it is giving the in instruction, it will enter here, and here it is going to read the status of the input output module. What is the status of input output interface, whether it is busy handling any other process or whether it is idle for the reading the data. All those kind of status will be checked here. So not checked here, it will be read. It will be read from the input output interface unit. Then it is going to check the status. If it is ready, that means what? If the input output interface is ready with the keyboard character, if the input output interface unit is ready for receiving the data, then the word will be read from the input output module, then it will be returned to the memory, right? Otherwise, if the status says the system, input output interface is not ready, it will go back and it will be reading the status again. So this part will be entering into the loop until the input output interface unit is ready for serving the CPU. So this is why we call it as programmed input output, because ee oru part vannittu ningal oru program aittan ezhudua. So this program will be continuously executed by the CPU. We call it as programmed input output. Now, so if I want to have the operation of programmed input output, these are the different steps done here. The processor is executing a program. What do you mean by this program? Some assembly program. You have written a program for adding two numbers in 8085 instruction set. Or you have written a program for adding two numbers in 8086 instruction set. That is what you call as this program. And this program encounters an instruction relating to input output operation. Suppose say you are writing a program in 8085 instruction set for adding two numbers. So what you will do, you will read the first number from the user, you will read the second number from the user. So if you want to read the number from the user, you will use an in instruction. If you want to read the second number, you will use the in instruction. So these in instructions is available in a program for the input output operation now. And after the addition of number 1 and number 2, you want to display the result. So that is also related to the input output operation. Appo what you will do, you will be using an out instruction. Now the processor then executes that instruction. Ivide instruction ഞാൻ mean ചെയ്യുന്നത് in instruction and out instruction by issuing a command to the appropriate input output module. So when you have in instruction, the appropriate command will be given to the input interface unit. When you give out instruction, the appropriate command will be given to the output interface unit. Then what the input output interface unit will do? Here input output module means input output interface unit. It will perform the requested action. What action is requested? The CPU wants to read a data from the keyboard, or the CPU wants to write a data on the monitor. So it will requested action based on the input output command issued by the processor. It may be a read command or a write command, and it will set the appropriate bits in the input output status register. So this bits what you are going to write in the status register will be periodically checked by the process, the status of the input output module, until it finds the operation is complete. So for this particular set of operations, I am going to show you a diagrammatic representation of programmed input output interface unit. You have a CPU here, you have an input output device, and in between I am going to have an interface unit. So if it is going to be programmed input output, you need a data register which acts as the buffer. So So if it is a input command, if it is a read command in the CPU, the data will be read from the input device and it will be stored in the buffer, right? If it is going to be a write command by the CPU, then whatever data is available in the data register, that will be given to the output device. This is how it is going to function. Now what happens whenever there is a input command or output command coming from the CPU, it will be waiting for the interface to receive the data or to send the data. I repeat, whenever there is a input output command in the CPU will wait for the interface to receive the data. എപ്പോഴാണ് interface receive ചെയ്യുക? If it is going to be a input operation, or to send the data. എപ്പോഴാണ് interface send ചെയ്യുക? If it is going to be a output operation. So the CPU will wait for the interface to receive or to send the data to the peripheral device. So by the time when it is waiting for the interface to receive or to send the data, it will continuously check the status of the device. It will continuously check the status of the device. How will you get the status of the device? Inside the interface unit, there is a status register which acts as a flag, and when suppose say for example you press a key, so what happens now? When you press a key in the input device, the data goes into the data register, right? So that means what? The input value is ready for the CPU to receive. The input data is available in the buffer. Now the CPU can receive the data. So by the time the flag bit will be set. Okay, how it will be set? There is a data valid line coming in. So the input device will set the flag in the status register. So this flag bit will be checked by the CPU, and if the flag bit is okay, if it says it is ready for receiving or sending the data, then the CPU will be taking the data or sending it to the output device. So this is what you mean by, here it says the processor will periodically check the status of the input output module until it finds the operation is complete. What do you mean by that? Operation എപ്പോഴാ complete ചെയ്യുക? ഒരു key press ചെയ്തിട്ട് ആ keyൻ്റെ data must be moved to the data register. You press the key here in the input device, and the data must be moved to this buffer. Only then the input operation will be completed. So until this input operation is completed, the CPU will be checking the status register. Why? ഇവിടെ നിന്നുണ്ടായിട്ട് ഒരു ഡേറ്റ രജിസ്റ്ററിലേക്ക് മൂവ് ചെയ്താൽ immediately the flag bit will be set by the input device. It will be sending the data valid signal because it says there is a valid data available in the data register. CPU can take that data. Yes, the same way if it is going to be an output device, what it will do? Data accepted signal will be sent. So once the data accepted signal is sent, the output device will be receiving the data from the data register. So this is what you call as programmed input output. So these are the different operations done during the programmed input output data transfer.